guys, hello friends, hello G's. It's your boy again, Falling with a Star. So guys, today we are going to look at cell structure as a course. And for this course, it's all about the cell, the functions of the cell, its components, and the functions of its components. But the question is, have you seen a cell with your naked eye before? The answer is no. You cannot see the cells with your naked eye. They are very small. And because of that, we need the help of a certain device in order to see the cell or any other small species. And that device is no other thing than the microscope, the almighty microscope. You understand? And because of that, this core cell structure also helps us to know more about the microscope, the functions of the microscope, its types, its techniques, and how they help us to see these cells that we want to study. And because of that, let's first look at the microscope. Why microscope? I've said this already. As I said, the cells are too small to be seen with the naked eye. Therefore, we need the microscope because this, our naked eye, can only distinguish between objects as small as 0.1 millimeters. So they can distinguish only objects as small as 0.1 millimeters. Anything lesser than 0.1 millimeters, our eye cannot see it. You understand? Therefore, we need the help of what? A microscope. But anything larger than 0.1 millimeters, our naked eye can actually distinguish or can see. Let's look at these mathematics here. We all know this back in SHS that 1 micrometer is equal to 10 raised to the power minus 6 meters. And 1 nanometer is equal to 10 raised to the power negative 9 meters. And here I want to add one thing to it. 1 angstrom, this is very examinable. 1 angstrom is equal to 10 raised to the power negative 10 meters. 10 raised to the power negative 10 meters. They can, in exams, they can ask you that 10 angstrom is equal to, because 1 angstrom is equal to 10 raised to the power negative 10 meters, 10 angstrom will be equal to what? 10 raised to the power negative 9 meters, because the 0 added to the 1 will actually, you will deduct it from the power here, making it what? Negative 9. You understand? Now, the question is, why am I talking about all these things? I'm talking about these things because these cells and its components that we want to study, they are being measured in micrometers, they are being measured in nanometers, they are being measured in angstrom, and this is far smaller than what our eye can distinguish, which is 0.1 millimeters. And that's why we need the microscope to see the cell and its components. Hope you understand. Now, there is the need for us to know the functions of the microscope. This is the microscope, you understand? And now there is the need for us to know the functions of the microscope. The microscope that we are talking about actually serves 2 functions. It serves what? 2 functions. And these functions are said to be dependent on each other. They depend on each other like twins. One cannot go and leave the other. They move together. And this is how these functions are. They are interdependent. And these functions are 1, magnification, and this is something we know back in SHS. Magnification, which is also known as enlargement. But the last one is the new thing that I'm going to add. The second function is what? Resolution. We will look at these functions in detail, don't worry. So the first one is what? Magnification, and the second one is what? Resolution. Someone may ask, what is resolution? You see, for resolution, the microscope, resolution is when the microscope helps to what? Render 2 objects as separate entities. Let me use this to explain for you to get what I'm saying. You see this large dot here. You see it as one large dot. But with the microscope, this is the view that the microscope will give us. You see that the microscope will make us understand that this large one dot consists of many smaller dots. You understand? It consists of what? Many smaller dots. So this many smaller dots comes together to give us what? This one large dot. You understand? And that is what? Resolution. Hope you understand. And that is what? Resolution. So now let's look at the reason for the interdependency. Why am I saying that magnification and resolution are dependent on each other? Let me use this scenario. Let's say that when you take a picture of someone, when you zoom in, you see that the picture becomes larger. That is magnification, right? But as you keep on doing that, it gets to a point where the image becomes blurry. And this is because you only increase the magnification and you forgot to actually improve what? The resolution. Understand? And because there is no improvement in resolution, that's why the image appeared blurry. You understand? So it means that an increase in magnification without an improvement in resolution is of no use. And that's why magnification and resolution are dependent on what? On each other. Hope you understand. Let me use these microbes here to actually make you understand it better. You see these small microbes here. When you increase magnification, you will see the microbes, but without resolution, it will be very difficult for you to see that this microscope, or it will be very difficult for you to distinguish between what? These small microscopes as what? Separate entities. You see them as one thing. You don't see that it consists of many of them. You understand? And that's where what resolution does. It helps you to see these things as what? Separate entities. Hope you understand. Yes. So magnification without resolution is what? Of no use. Now let's look at the various functions into detail. So let's look at magnification. We all know the definition for magnification. Magnification is just the process of enlarging something only in appearance. The key word here is only in appearance. When you use the microscope, you see that the object becomes larger, but that is only in appearance. But in reality, the object is still of the same size. You understand? And that's what? Magnification. And people mostly confused magnification with what? Resolution. Note that resolution is just the ability of what? An imaging system. For example, the microscope. Microscope is an imaging system. So it's just the ability, let me say, the ability of the microscope to show detail in the object that is being viewed or that is being imaged. You understand? So to show detail in the object that is being viewed or being imaged. For example, these microbes I said, without resolution, you cannot see them as what? Separate entities. You see it as one thing. You understand? But resolution helps you to see that they are separate entities, and that gives more detail to what you are viewing. You understand? So that is it. This magnification that we are talking about depends on certain things. It depends on two main things, and they are: one, the focal length of the lenses. The focal length of the lenses. You see, when you're using the microscope consists of what? Lenses. We have the eyepiece lens and we have the objective lens. You understand? And magnification depends on the focal length of the lenses, mainly the objective lens, but it can also depend on what? The eyepiece lens, but mainly on the objective lens. It also depends on the mutual arrangement of the lenses. We'll look at these things into detail. Now the question is, what is focal length? Let me use this diagram to explain focal length. This is the lens. The light rays are coming from this person, you understand? And they are being brought to focus at this point. So the focal length is just the distance between the lens and this focal point. You understand? So the distance between this lens and the focal point is the what? The focal length. You understand? And this focal length can actually determine whether the magnification is higher or lower. Why am I saying this? You see, the shorter the focal length, the higher the magnification. Because if the focal length is very short, it means that the optical power of this lens is very strong. the optical power of this lens is very strong, and that's why it was able to bring the light rays into sharp focus at a short distance, and that actually gives what? A higher magnification. But if the focal length is long, it means that the optical power of this lens is weak, and therefore that's why it brought the light rays into focus at a longer distance, and that gives what? A lower what? Magnification. Hope you understand. Yes, so that's how focal length affects magnification. So in short, we can also say that the focal length measures how strongly the light rays converged. It measures how strongly the light rays converged. If the focal length is short, it means the light rays were strongly converged. But if it is long, it means it was the light rays were weakly what? Converged, and that gives a low magnification. Hope you remember. And as I said, the shorter the focal length, the higher what? The optical power, and the higher the magnification, and vice versa. Meaning, different focal lengths give different levels of what? Magnification. So whenever, and note this, whenever you see a lens with a description of 50 millimeters, that 50 millimeters on it is an indication of its what? Focal length. So put that in mind. Understand? Yeah. I want to talk about this terminology here. Parafocal lens. Parafocal lens. What is a parafocal lens? A parafocal lens is a lens that stays in focus even when magnification or focal length is being changed. How do we change magnification when it comes to the microscope? We change magnification by changing the objective lens. You understand? Each of the objective lens has its magnification. So as you change the objective lens, the magnification also changed. For the objective lens, some microscopes have 3, some have 4. You understand? We have the scanning objective lens, that is the 10 times magnification. 10 times it is the lowest. You understand? And we have the low power objective lens, which is 40 times. We have high power, which is 100 times, and we have the oil immersion lens, which is the highest of all. Hope you understand. And when you are using the microscope, when you use, let's say when you use the low power lens to view a specimen, and you bring the specimen into focus, when you change the lens from the low power to high power, the specimen that you brought into focus will actually move from the focus point. You understand? You have to actually suffer to bring the specimen back into focus, and this is what the focal lens prevents. Because for this this is what the parafocal lens prevents. For the parafocal lens, it still remains in focus even when you change magnification or when you change focal length. Hope you understand. That's it. Working distance. You see, I also said that magnification depends on what? The mutual arrangement of what? The lenses. The mutual arrangement of the lenses. This is where it comes into play. Now the question is, what is working distance? Let me use this diagram to explain. You see, the working distance is just the distance from the tip of this lens to the topmost of the specimen. You understand? From the tip of the lens to the topmost of the specimen is the what? The working distance. You understand? And this working distance affects magnification because the longer the working distance, if the working distance is very long, it gives a very low magnification. And if the working distance is very short, it gives a high what? Magnification. And scientists are very brilliant in such a way that they've designed the objective lens in such a way that the one with the low power magnification is very short, meaning that when you are using it, the working distance will be long. You understand? And the one with the high power magnification is very long, meaning that when you are using it, the working distance will be short, and it will give you what? A high magnification. You understand? And that's why, and that's what I mean by the mutual arrangement? The mutual arrangement just talks about how far or how close the objective lens is towards the object being viewed. How far or how close the objective lens is towards the object being observed. You understand? So if it is very close, it gives a high magnification, but if it is far, it gives what? A low magnification. Let me use this scenario. Let's say that there is this building, but you are far away from the building. You see the building as very small because the working distance is far, you understand, or is long. But as you move closer to what? The building, you see that the building becomes what? Larger, because now you are decreasing the working distance. The working distance becomes what? Shorter, you understand, and that gives you what? A high magnification. So working distance and magnification is what? Inversely what? Proportional, you understand. The higher the working the longer the working distance, the lower the magnification. The shorter the working distance, the higher what? The magnification, you understand. So that's it. Our next topic will be on resolution. That will be in our next lecture. And I'll also talk about the types of the microscope, where I'll talk about simple microscope and also compact microscope, the defects of simple microscope. Hope you understand. So stay blessed. Bye.